Hi guys, welcome to my channel. In this video we are going to solve a question about the reinforced concrete, and the question will be analyzed as a T-beam. So let's solve the question. In the question it asks determine the ultimate moment. So we are going to determine the ultimate moment of this beam. Let's solve the question. The first I'm going to start to understand that it is true beam. It is true beam and rectangular beam. The first of all, we are going to calculate the forces, because here, for example, this is tension steel, and we are going to have a concrete effect blocked here, and this will be a compression concrete. So for the compression concrete, 0.85 multiply design strength of the concrete 13.3 and multiply the B, this is B, and this is BW, and this is HF actually. So BW, what is BW? 1300. So, and this is HF, what is HF? 100. And this will be equal to 1,472,965 Newton, okay? So now I have this. Let's calculate for the tension steel also. And this will be area of steel that is used. Now in the question you can see all reinforcements are given, and I also calculated the area of steel for you. You can calculate it easy. It's not something hard. Multiply 365.22, the yield strength of the concrete, tension steel, and this will be equal to 573,687.576 Newton. Okay. And now let's make a comparison. You can see that the compression concrete is greater than tension steel. So this is a rectangular beam. Okay. Now the behave will be like a normal rectangular beam. So let's determine the this area, the depth of effective concrete area, and then we are going to calculate the moments. For them, I'm going to write an equilibrium. Okay, for the equilibrium, we are going to make them equal compression concrete and tension steel. 0.85, this is for the compression concrete, multiplied 13.3 and multiplied BW, so B is 1300. 10 is more, and I'm going to multiply it with 100 minus A, because if it is compression concrete, look at here, if the compression concrete is greater than tension steel, that means that HF greater than A. Okay, so if HF greater than A, now this is HF, we can say something like that. Actually, the effect of concrete is going to be in this area. Okay, it will be in this area. This will be the compression concrete area. So I subtract from the 100, and I'm gonna take it as equal to this tension steel force 573,687,576. And from this equation, I'm going to obtain the A as equal to 6.9 millimeter as the effective depth of the concrete. So now I have A, so let's calculate the moment. This is going to behave like a normal rectangular beam, okay? So the formulation will be compression concrete multiplied D minus A over 2. So why D minus A over 2? I'm gonna show you here actually. And this will be, I told you that it's going to behave like a normal rectangular beam. So for example, this is the effective concrete block. Okay, this length is A, and this total length until that point is D. And now this is the compression concrete. It's going to affect at the midpoint of this concrete block, and from that midpoint, when we take the moment with respect to that tension steel point, we are going to subtract A over 2, this half part, this half part from the D. We are going to subtract it from the D, and this comes from there actually. So let's make calculation. 1472, 965, and multiplied 560 minus 60.9 over 2. So from this calculation, we are going to obtain 780.01 kilonewton meter as the moment will be carried by this cross section. So now the moment also be determined. The question is solved. Thank you for watching. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. See you for the next question.